This is sort of a part two of using the distributive property to multiply, I guess, polynomials really, because in this one I'm going to do a trinomial and a binomial. So here's the problem I'm going to do: x plus 2 times the quantity x squared plus 3x plus 2. So what I'm going to do is first use the distributive property, so x times that whole quantity and then plus 2 times that whole quantity. So let's write that out. So x in that whole quantity, and then plus 2 times that whole quantity. Now what I want to do is distribute through. So x times the quantity will give me I've got x cubed plus 3x squared plus 2x, and then plus 2x squared plus 6x and plus 4. So that's all good. Now I got to collect some like terms. Well, I have 1x cubed, and here are my like terms for the squareds. So that'll give me 5x squared. I look for the x's, so I see 2x and 6x. Add those, you get 8x, and then a 4. And that's what we get. So let's try this one by doing the multiplication. So we're going to write it out like we would a multiplication problem. And go ahead. So 2 times 2 is 4, and 2 times 3x is 6x, and 2 times x squared is 2x squared. And I put in that 0 for a placeholder, and then multiply it out. And now I'm just going to add down. So everything ends up in the correct column if you put in that placeholder. So 4 plus 8x and plus 5x squared and then plus x cubed. And that's another way to do it. You can see we got the same answer. And then, just to show all the methods that I often employ, here's the geometric kind of area model. So what I've done here is I've made a 3x2 rectangle. 3 because I have a trinomial, and 2 because I have a binomial. So put the terms. It's important that you include the sign with each of the terms. And now what I'm basically going to do is find the area of each little rectangle. So x times x squared is x cubed, and so on. So x times x squared, and so on. And you can just kind of see it getting filled in there. If you put placeholders here, what's going to happen is along diagonals are the like terms. So you can see you got your like terms there. So an x cubed, and then we got 5x squareds, and then along this diagonal here we have 8 x's and then a 4. So jot down the final answer, and that'll do it. Any of these three methods are perfectly good, and they get us the answer, and that's what really matters. So I hope you find this helpful.